All right, week 35, part 3. So, this is some trig identity stuff. First type, first type of question says, please write in terms of sine and cosine and simplify. So, when we hone in on these things, we have to know that the cosecant is 1 over sine, secant is 1 over cosine. I remember that by the s's and c's are reversed. So we rewrite this, and with a lot of these, there's this whole fraction divided by a fraction, and so you know that dividing by a fraction is the same as multiplying by the reciprocal, so it's like this times cos over 1, which gives us this, which is the reciprocal of the tangent, which is the cotangent. There we are. Number 2, sine, secant, and tangent. So each of these individually, I'm writing sine is sine over 1 because I know there will be a fraction over here. Secant's 1 over cosine. Tangent is sine over cosine. So let's see, we got sine over cosine over sine over cosine. So dividing something by itself is equal to 1. Kaboom! Number 3, this looks suspiciously like the, we got the sine squared plus cosine squared equals 1. So we think it's going to come into play. 1 over secant squared is 1 over cosine squared. And so minus 1, and the 1 I immediately turned into cosine squared over cosine squared, so that I'd have common denominator right here. So these two, common denominator gives us this guy right here. And we have 1 minus cosine squared, so 1 minus cosine squared. So real common mistake right here is people would see, so we're down here, all right. Here's our numerator, and here's our denominator. Real common mistake is people would cross out these cosine squareds and just get 1. You can't do that. But this, the denominator and the denominator cancel out. If you are not seeing that, you could always multiply by cos squared over 1. And then you'd see that those cancel out. So we're left with 1 minus cosine squared, which is equal to sine squared x. Excuse me. Next one, say, use the addition or subtraction identities to find. So somewhere on your, I meant to show you that, but whatever, you know what it looks like. We have the addition and subtraction identities, and you'll notice with these questions that the angle for which we are finding the sine or cosine is some combination of 30, 45, or 60. So 15 we can think of as 45 minus 30. You could also do 60 minus 45. You get the same thing. And we rewrite it as this so that this is the way the formula looks on your formula page, so that we can apply it to this. So in this case, s minus t is 45 minus 30. So we got sine 45 times cos 30 minus cos 45 times sine 30. And using your unit circle skills, this right here, unit circle skills, there we go. And we find each of these, and then we have to multiply square roots and stuff. So root 2 times root 3 is root 6. Root 2 times 1 is root 2. And we simplify because we have this common denominator 4. And when you work through these homework questions, it was basically some combination of root 6 and root 2, either being subtracted or added, and either root 6 minus root 2 or root 2 minus root 6 over 4 for a lot of these. Anything that was kind of a multiple of 15, I think we saw that a bunch. So let's see. Oh yeah, 105. So this is a multiple of 15. We have cosine of 45 plus 60. So we're using this, cosine of something plus something. You could also do, well, let's leave it at that. All right. So we write it out, cosine of 45, cos 60, sine 45, sine 60. And again, unit circle, unit circle, unit circle, unit circle. Multiply, common denominator of 4. And voila. All right. Let's take a look at page 2. So over here, this is where we are using our algebra skills of solving equations, and using our unit circle skills to solve trig equations. And because we know that the angle, we know that the angle starts here and moves around like that, then it can keep going around and around and around. So when we say, let's say this angle right here is 1/4, 2/4, 3/4, 4/4, and 5/4 pi. Well, yeah, but if you went another 2 pi, you'd end up in the same place, and another 2 pi, you'd end up in the same place. So sine theta is negative root 2 over 2, so we know sine is y. Down here, root 2 over 2 would be a 45, 45. So we have these two triangles. And this angle is 5 pi over 4 plus 2 pi k. So this means k can be any number, 0, 1, 2, 3, 4, 5, so any integer, sorry. And this angle moving around any amount of times will end up in the same spot. And same for this over here, 7 pi over 4 plus 2 pi k. All right. So again, this is more unit circle. There's no algebra involved in getting the trig function all by itself. But we know tangent of theta equals 1. So that's where the sine and cosine are the same. So it'd be like this, right? Positive root 2 over 2, positive root 2 over 2. Or here, negative root 2 over 2, negative root 2 over 2. So we have pi over 4 plus 2 pi k, or 5 pi over 4 plus 2 pi k. But we can write that more simply as we have this angle, and if we went pi radians, we would end up here, and if we went another pi radians, we'd end up here again. Pi radians end up here again, pi radians end up here again, etc. So we could just say like this, pi over 4 plus pi k. And this mostly just, the pi k instead of the 2 pi k mostly just shows up for tangent as a general rule. Alright, so here we got a little bit of algebra. We got root 2 cos theta minus 1 equals 0. So use our algebra skills. We're going to add 1 to both sides. And we're going to divide both sides by root 2. 1 over root 2, and that's the same thing as root 2 over 2. So the idea is to get the trig function all by itself first, and then use your unit circle skills. So we're finding the inverse cosine of root 2 over 2. And we're using our unit circle and triangle skills. So we know that the cosine is positive root 2 over 2. So it'd be this triangle or this triangle. So we have pi over 4, or 7 pi over 4, plus 2 pi k. So we would end up with these sort of two separate answers, like so. All right, and then lastly, so you do know how to factor. I know that it might not be the most fun thing, but you do know how to do this. So you see this crazy equation, and instead of writing in terms of sine of x, we're just going to choose some different letter. It could be b or z or y. So I'm going to say y equals sine x, and I'm rewriting this so that it looks easier for me. 2y squared plus 9y equals 5. And I put everything on one side with a 0 here, because that's what we need in order to factor. And so you'd set up your parentheses, and you're thinking, what do my firsts have to be? You know you need a 2y and a y, and then the last, a 1 and a 5, and jiggling the positives and negatives gives us this. So this is going to work. Our outers are 10y and inners minus 1y, giving us 9y. So what this tells us is that 2 sine x minus 1 equals 0, or sine x plus 5 equals 0. So we set this equal to 0, and we get y, or sine x, equals 1/2. Set this equal to 0, y, or sine x equals negative 5. So this is no solution, right? Within the unit circle, the largest value that sine can have is 1, and the largest negative value that sine can have is negative 1. So negative 5 would be way down here. That's way off the unit circle. No solution for this part of our equation, not for the entire thing. This is all good. Y equals 1/2, so that would be right here. And we'd have that triangle and this triangle. So we end up with, yeah. So we end up with over here, this would be pi over 6 plus 2 pi k, around, around, around. And this angle over here would be 5 pi over 6 plus 2 pi k, around, around, and around. So here is our answer. Okay, thanks for listening.